Welcome to Sundar's lecture, and this is lecture number 33. And what are all the topics we have seen in the last class? See, we have taken this one, right? So, IRMS, we have found what is the root mean square value of an AC quantity, and we have ended up with the expression Im by root 2 or 0.707 Im. And we have also discussed about the importance of RMS value. Why we need to find RMS value for an AC quantity, right? So we have compared with the DC, that means I is equal to 5 ampere DC, and we have taken that as, and we have taken a circuit with a 10 ohms resistor, and how this 5 ampere source is connected to the 10 ohms resistor, and how this 10 ohms resistor is producing heat energy to the atmosphere by the 5 amps DC source, whereas if you are going for a AC source, you need to give a extra current, right? It is this is the maximum value in the DC, and we need to give extra maximum, right? We have seen this. If in DC, if it is a 5 amperes, then in AC it has to be 7.07 maximum current value should be there to produce the same amount of heat. That is what we have seen in the previous class, right? Now we try to find what is the average value of an AC quantity. Right? This one we have already seen anyhow. Uh, we try to do this, right? We try to do by ourselves. So we know already, right? What is that? What is average value? What is average value? So average value, which is equal to, we have already seen this. What is that? Area. Here it is. Area under the curve divided by total length or length of the curve. This is the formula we have already taken. We know this one because in RMS value also we have written this, and we have squared this value. Since RMS value, while taking the RMS value, we have to square this term and you have to take square root for whole term, right? So we have seen. So for area under the curve, what we need to do for area under the curve, we directly substitute these values now, which is equal to average value, which is equal to area under the curve, we know, right? So this has to be integration of 0 to pi, 0 to pi, see, integration of 0 to pi, and what is the value, we know, right? I is equal to, we can write here itself, I is equal to Im sine omega t, or it may be theta, right? Or it may be theta, we will take theta here. So this will be Im sine theta into d theta, or it may be omega t into d omega t, any of them, both are same. And what is the total length? The total length will be what? That will be 1 by, that will be pi, right? So here in this term, in this integration term, Im is the constant, so we take a constant outside, so that will be Im by pi. And if you take integration for sine theta, it will be minus cos theta, right? So this will be minus cos theta, and what is the limit? That is 0 to pi. So if you substitute this limits inside the terms, Im by pi will be there, and the upper limit will be minus cos pi, and the minus value will come here, then cos 0, right? So what is cos pi? Cos pi, which is nothing but, here it is 180 degree, right? So 180 degree, cos 180 degree will be minus 1, and minus 1 minus 1 become plus 1, and this value cos 0. Okay, you see minus cos pi, then there is a minus already there, then this has to be plus, right? This has to be plus. I have made a mistake. This is plus. So cos 0 value will be 1. So 1 plus 1 will give you what? 2. So finally we will get Im by pi into 2 into 2. So this is the final expression. So I can write I average. I average because I have taken I here. So I am writing I average. I average will be is equal to 2Im by pi, or in terms of fractional values, it has to be 0.637 Im. 637 Im. So you see, this is the final expression for average value. So see, we have taken current here, but also we can write it for voltage values. So you see, this is default. You have to understand these kind of things. V average should be what? 0.637 Vm. That's all. Huh? Likewise, you can write for VRMS. What is VRMS? VRMS will be equal to what? I will write here. So VRMS will be also equal to what? Vm by root 2. That you have to understand, because both expression will have the sign quantity. So this is the average value. Right. Now we will take another term, that is form factor. Form factor. So what is form factor? A form factor will be denoted by Kf, the ratio of RMS value to average value of an alternating quantity. That is nothing but it is form factor. So RMS value by average value. Right? We know now how to substitute these values. What is RMS value? That is nothing but it is Im divided by root 2 divided by root 2 whole divided by what is average value, right? We can do this one, right? So this will be 0.637 Im, right? So if you substitute these values, Im and Im will be cancelled out and you simplify this, right? 1 by root 2 into 0.637, all those kind of things. Then finally you will get Kf will be equal to 1.11. So this is the final value of Kf. This is constant value. This is a constant value, that is form factor will be always what? 1.11. Next one, peak factor, that I will write down. So next one, peak factor or crest factor, and we always say this in Kp. This is Kp. So the ratio of maximum value to the RMS value. So what is maximum value? We know this, right? Maximum value will be what? This will be Im divided by what is RMS value? RMS value we know this is 0.707 Im, and here Im and Im will be cancelled out, and finally we always get Kp will be equal to 1.414, that means 1 by root 2, right? This is 1 divided by root 2. So Kp, this is a constant value, that is peak factor or crest factor value will be always 1.414. These two are constant values, right? Okay, form factor and crest factor will be always this 1.11 and 1.414 respectively. So what are all the things we have seen till now? So we have seen what is RMS value and what is average value, what is the form factor, what is the crest factor or peak factor, and we have also seen this one, right? So there are so many expressions we have already seen. So what is the instantaneous value, what is frequency, and what is time period, and what is omega, everything we have seen already, So we take an example, and we try to find all these values from the example problem. Right? So this is the problem we have taken. Example number 1. The equation of an alternating current is given by I is equal to 42.42 sin 628t, and we need to find these parameters. That means maximum value, frequency, time period, RMS value, average value, peak factor, and this is form factor Kp, Kf, and what is the value of I when time t is equal to 2.5 milliseconds, which means what is this one actually? This is instantaneous value. At t is equal to 2.5 milliseconds, what is the value of current? and the last parameter we need to find what is the angular frequency. Now we try to write this expression in the standard form. So how will you write? So I will be with equal to Im sine omega t. So we know this one. We have already seen this standard form of writing the alternating quantity. Now we try to write this expression here and we try to relate the two expressions. That means I, which is equal to 42.42 sine 628 t. Right. Now you see from by comparing these two expressions, we can easily find what is Im and what is omega. Both are given in the question itself, right? So we try to write that one. So how will you write? So the what is the maximum value? What maximum value, which is nothing but this is Im, right? So first answer. So we can directly write, that means Im, which is equal to 42.42 amperes. It is very simple to write. And also omega, what is omega? That is nothing but angular frequency, right? So angular frequency is also given. What is that? So ninth answer, that is omega, which is equal to 628. So this is also given, right? Very simple. Now we try to find what is the frequency. How will you write frequency? We know. So for the second question, so frequency, we know omega, which is equal to 2 pi f, right? So this expression we already know this one. So from this f will be equal to omega by 2 pi, which means I can easily substitute. I know omega, that is 628. So 628 divided by 2 pi, that we know. So if you simplify this, so this will be nearly equal to 100 hits. So 99.95, I am just writing it as 100. So we can write the second answer. That means frequency f will be equal to 100 hits. We have found. So next one, time period t. What is time period t? We know the formula to find time period. Time period t will be equal to what? 1 divided by f. We have already seen. This, right? So then t, which is equal to 1 by 100, that should be equal to what? So that should be is equal to 0.01 seconds, or we can write it as, so that is 3 time period will be equal to 10 milliseconds. 10 milliseconds, right? So what is this time period? Time taken to complete one cycle. Right? What is one cycle? One positive half cycle, one negative half cycle. That we try to draw the diagram. So I will draw the diagram anyhow. So you see, I have drawn the graph here. So we know, right? So this is 42.42 is the maximum value. So you see, this is the positive maximum value, that is 42.42, and the negative maximum value will be what? Minus 42.42. And what is the time taken to complete one cycle? That is 10 milliseconds. So you see, this is one positive half cycle, this is one negative half cycle, and that has been completed within 10 milliseconds. So this is 0 and this is 10, this is 2.5, 5 milliseconds, 7.5 milliseconds, and this will be the 10 milliseconds. So this is how we can draw the diagram of an alternating quantity, that is the current of the given expression will be drawn like this. So we have found this values. Now we need to find what is the RMS value, average value, and KP and all those kind of things. So that for that we will take a new page. So we need to we try to write the expressions first of all. So I will be is equal to 42.42 sine 628 t. That is the given value. And also we know that I, that is equal to, sorry, Im. So Im which is equal to 42.42 amperes. So we need to find what is the RMS value, right? So next one, that means IRMS should be is equal to IM by root 2, right? This is the formula. We already seen this one, right? That is what we have found in the expression. So IRMS will be is equal to what? IM by root 2. We know this one. So IM by root 2. What is IM here? What is IM? IM will be is equal to 42.42, right? That has to be divided by root 2. And what is the final answer? So this comes out to be what is the value? This comes out to be 30 amperes. Nearly it is 29.99 and we have written it as 30 amperes. Next one we need to find I average. What is I average formula? We have seen that this is 0.637 into IM. So if you substitute the values, what you will get? 0.637 into 42.42, right? 42.42, and this comes out to be 27 point. That means I average will be is equal to 27.02 amperes. So this question, this is question number 4 and this is 5, right? So this is 4, this is fourth question, and this is the fifth question. And what is the next one? What is the next one? So next one, that is Kp, right? Peak factor, Kp. Sixth question. So I will write here sixth question, Kp. What is the formula for Kp we have seen? See, Kp is equal to what? Maximum value by RMS value. Maximum value by RMS value. So I will write down here Im by I RMS, right? So we know both answers. This is IM, which is nothing but this is 42.42, and this divided by what is the RMS value? RMS value we know this is 30, right? This is 30. And this value comes out to be Kp, that is constant. I have told you already, right? 1.414. You see, that is what we have seen here too, right? You see here, this has to be what? 1.414, right? So that is what we have got here also. So Kp. This is the sixth question, right? This is sixth one. And the seventh question is what? Seventh is peak form factor. Form factor, right? What is the formula for form factor? RMS value by average value. RMS by average value. So form factor, that is Kf RMS. That means I will write like this: I RMS divided by I average value. So what is the RMS value? RMS value is 30 divided by what is the average value? 27.02. 27.02. And if I simplify this, Kf, that has to be is equal to 1.11. This is the seventh question, right? That is also constant. So next one, you see this is very important. What is the value of I when t is equal to 2.5 milliseconds? In 2.5 milliseconds, at 2.5 milliseconds, what is the value of I? See, that we can find it from the graph itself. See, this is the graph we have seen, that is 10 milliseconds. For one cycle, it takes 10 milliseconds, and we have drawn this graph now. And from here itself, from the graph itself, we can go by here. This is 2.5 milliseconds, right? At 2.5 milliseconds, what is the value here? That is nothing but it is maximum value 42.42. Right, what is the value here? At this instant, what is the value of current? That is nothing but it is maximum value 42.42, right? If you draw the graph, then instantaneous values are very simple. Instantaneous values are very simple, that we can easily get from the graph itself, right? So I will write here for the eighth question, for the eighth one, at t is equal to 2.5 milliseconds. What is the question? What is the instantaneous value of current? What is the instantaneous value of current? And from graph, I will write here, from graph, we can easily find I at 2.5 milliseconds will be equal to 42.42 amperes, that which is nothing but it is Im. That is nothing but it is Im. So we can finally write I at 2.5 milliseconds will be equal to 42.42 amperes. So this is the question number 8. Right, we have found all the questions, all the answers, right? We have found maximum value and angular frequency we have already found, right? So you see, you see all the values we have found by using the simple expression. From this expression itself, we can find different parameters of an alternating quantity. Right? You just go through this problem and you will get many ideas related to the alternating quantities, right? So with this knowledge, we try to find what is the value of power when we give an alternating quantity or an alternating voltage or current to a resistor, inductor and capacitor. That is very important. This RLC circuit plays a major role in the basic electrical engineering or in the electrical circuits. So you have to know what happens when a AC quantity is given to resistor, inductor and capacitor, and when what happens when a AC quantity is given to a resistor inductor, a resistor capacitor, a resistor inductor capacitor circuit. And if you know all these basics, then it will help you more, help you to learn or to know the basics of electric circuit, the approaching AC circuits with a better knowledge. So you just try to understand things with me in the forthcoming classes, because it is very important to learn RLC circuits. For that we should know what is this one RMS value or all those kind of basic quantities that we have seen from an example. Thank you. We will see in the next class.